Hello everyone, welcome back. This is a video on an infinite series that we are solving, and it has a use of differential equations in it. So let's get on with it. First of all, I'll just simply break this into partial fractions and take it as two different series. And this, right? So S1 can be this series. Let's say this is S1. So S1 as a function of x is minus x power 2, sorry, minus x power 2 by 1 plus minus x power 3 by 2, and so on. So if I just divide by minus x, this would be minus x power 1 by 1 plus minus x power 2 by 2, and it goes on. So if I differentiate both sides, also this is an infinite series, so obviously I can just leave it like this. So if I differentiate on both sides, I would be left with s1 x by minus x. Also this is just the function, so I'll just leave it like this. Okay, so let's say s1 is just a function of x, f1 of x, let's say. So this should be minus x power 0 plus 2 times minus x power 1, and so on. Let's take another term, let's say 2 3 by 3. So all of these cancel and I would be left with 1 minus x plus x squared minus x cube, and so on. So this is just the infinite GP with mod x less than 1, which is already given in the question. So I can just say that minus 1 upon 1 plus x should be s1 upon minus x dash. This was the differential of it, right? So s1 upon minus x should be the integral of this, which is minus ln mod 1 plus x plus c. So to calculate c, also some of us might be tempted to just say that s1 upon x square should be the differential of it, but that's wrong because s1 is a function of x, so that is completely wrong. Also, to find the value of the constant, obviously I can say that s1 of 0 is equal to 0, but I can't put it directly here because obviously I can't divide by 0. Rather than that, I can take s1 upon x, s1 upon minus x to be this thing. So this would be minus x power 1 by 1 plus minus x power 2 by 2, and so on, is equal to minus ln mod 1 plus x plus c. And obviously putting x is equal to 0 in this, I would be left with 0 is equal to minus ln mod 1 plus c. So c is 0, so no issues in that. So s1 is basically x ln mod 1 plus x, right? Okay, so let's go on to s2. S2 is basically n is equal to 1 to infinity minus x power n plus 1 upon n plus 1. So this is minus x power 2 by 2 plus minus x power 3 by 3, and so forth. So again I can just differentiate both sides and I would be left with minus x power, okay, minus 2 times minus x power 1 by 2 plus 3 times minus x power 2 by 3, and so forth. So I am left with minus times minus x plus x squared minus x cube, and similarly that. So this is x minus x squared plus x cube minus x power 4, and just like that. So this is x upon 1 plus x, right? S2. So s2 dash, I can write it that way. I hope that's fine. Yeah, so s2 is equal to the integral of this, which is basically 1 plus x upon 1 plus x minus 1 upon 1 plus x. So s2 of x can be written as x minus ln mod 1 plus x plus c, and again s2 of 0 is equal to 0, which I can probably put directly here, right? 1 plus c, so again c is equal to 0. So s2 of x is equal to x minus ln mod 1 plus x, and yeah, that's it. I think other than that nothing is left. S1 minus s2 is the answer. So s1 minus s2 will be x ln mod x plus 1 minus x plus ln mod x plus 1. So this is x plus 1 ln mod x plus 1 minus x, s1 minus s2. Yeah, okay, thanks for watching.